Sources in modular synthesis are where the sound originates, and sources are generally one of two types, either the VCO style, that is voltage controlled oscillator, or a noise source, and we'll consider both types. The circle symbol denotes a source, and then you put a little symbol on the inside to give some idea of what the wave shape is. We might have a sine wave or square wave, triangle wave, all the kind of things that are common for the function generator in the electronics laboratory. Again, these are all wave shapes that were easily generated in transistor-based analog electronics. So if we consider the characteristics of the output of any one of these voltage-controlled oscillators, and I'll pick the sine as an example here, we would just see a perpetual sine wave, and the sine would be, in terms of amplitude, will be at a constant amplitude, and it will be at the maximum amplitude. So therefore, it's up to some other device to be able to attenuate the signal to make it softer if necessary. In terms of harmonic content of these waveforms, the sinusoid has only a single harmonic at its fundamental frequency, so that way it's a pure tone. A square wave will have harmonics located at odd multiples of the fundamental frequency. For example, at 3 times the fundamental frequency, 5 times, 7 times, and so forth. The triangle wave actually has harmonics at the even harmonics as well, but the harmonics at the higher values tend to die off faster than they do for the square wave. So we could say that the square wave and the triangle wave tend to be the richer amount of harmonics, but the square wave has only the odd harmonics, but it's the strongest harmonics. Triangle wave has all of the harmonics, but they tend to be lower intensity. Now, every one of these voltage-controlled oscillators will have an input for the control voltage, and it's this control voltage that establishes the frequency of the output. And commonly, this control voltage would be established by a keyboard, but it could also be established by things like sliders or knobs or some other sort of human interface mechanism. A possible standard would be 1 octave increase per volt of increase. What's an octave? Well, that's a factor of 2 increase in the frequency. So if we say play a note and then play a note that's an octave above, it will be exactly twice the frequency of our first note. Now, noise sources are important as well because these become the basis of generating percussive sounding instruments. So again, this is another type of signal source, and we have the circle symbol for that. And the output will also be a fixed amplitude signal, which again can be attenuated or that is reduced in amplitude by some other device as needed. So these become the basis of any kind of percussive or noise-like sound that you might need.